Greetings everyone, today we will in second chapter basic mathematics. This will be the first lecture of this series. Second chapter basic mathematics. Lecture first. So in this lecture students we will discuss algebra, basic algebra that is required for physics. Basic algebra So basic algebra, an example of it, x plus y cube happens to be x plus y cube plus 3xy x plus y. So this is actually x plus y cube, which can be written as follows: x cube plus y cube plus 3xy 3x square y plus 3x y square. Okay students, so the idea is not the identity but the binomial theorem. But what if x plus y is x plus y raised to the power of 4 or 5 or anything. So this power here is becoming any number n, and it is going higher and higher or anything like that, any number. So Sir Isaac Newton came with this formula. It is officially credited to him, the binomial theorem, and he stated in his book Principia Mathematica. So here binomial theorem states x plus yn is such that nc0 happens to be nxn y0 nc1 xn minus 1 y1. This goes to infinity till ncn x0 yn. Okay students, so this is the basic thing. So this is n combination and the remaining number. NC n combination 0, NC n combination 1, n combination n. So this is read as n combination 0 and as follows. So I would actually write here the thing where this is a thing to be discussed. What is n combination 0 or anything like that? N factorial r factorial n minus r. Yes. So n is the total number here students, and total number, r happens to be remaining number. So this is n, the total number, and 0 is the remaining number, and as follows. So you would say, sir, could you give an example of this? It's certainly a beautiful formula for any n, but what is if you could just give an example? Example 3 factorial, 2 factorial, 3 minus 2 factorial, and this happens to be what is, students? 3 into 2 into 1. So you stop till 1 in every number. 2 into 1. So this is the thing, and answer becomes 3. Okay. So till 0 we will take, and 0 factorial is also 1. So just ignore the background noises. So 0 factorial is also 1. So this actually where it all leads to is binomial theorem of any index or power. Binomial theorem, certainly binomial theorem of any index, for any index. For any index power. Okay. So here the theorem states that if x modulus is smaller than 1, x is such that it is smaller than 1, then we have actually plus 1. So modulus here stand for this meaning, implies that minus 1 and such that, and n is such that n happens to be positive, negative, or even fraction, no space formula. So you see, 1 is being in comparison to x. 1 is being in comparison to x. So if I take in the formula 1 as x, then y should be taken as x, and the formula of x plus y n becomes 1 plus nx. Right, students? This becomes n minus 1 x square 2 factorial, and this happens to be n minus 1 n minus 2 x cube and 3 factorial. Okay, students. So this is the thing. Now let me give an example for your better understanding. So the beauty of mathematics is that it satisfies every number. The formula satisfies every number whatsoever. They can be special cases, but expand example expand 1 plus x raised to power minus 2. So this is the thing here. In the solution part as goes, so you put into the formula the thing, and it becomes 1 x minus 2, and this is actually very careful with the numbers, plus minus 2 minus 2 minus 1 x square 2 factorial. This happens to be minus 2 minus 2 minus 1, and again minus 2, I am writing here minus 2 x cube upon 3 factorial, students. So the equation finally becomes 1 minus 2x 3x square minus 4x cube. So this goes as follows until infinity. So it is an infinite series. So the higher you go into the infinite series, the more exact value you get. So you would say, sir, it is quite interesting how high we can go. So the more you go into the infinite series, the more it is, the more exact it gets. Application part of it, example 1.1 minus 2. Okay, so this number is written in this form. Okay, students. So how you are saying it is written in this form? So let me write 1 plus 0.1 minus 2, and this certainly can be written as 0.1 square, and this happens to be, now apply the formula to it, and this becomes 1 minus 0.1, yes it is right, 3.01 square, and again minus 4, 0.1, and goes to infinity. So this is the answer to it. Certainly you put into these values and you get 1.1 raised to power minus 2 as the value. You can check on your calculator. For if, now the next part, for if x is such that it happens to be, second case it is, for if x is such that it happens to be x plus 1, right students, then this remains this formula. Certainly not. Certainly not. So here's a different case to this scenario. We will use certain method of reduction here. what it is. So then the formula of 1 plus x n becomes equal to what, students? 1 plus nx. So you have noticed equal to sign doesn't come, approximate sign comes. Okay. 1 minus x n 1 minus nx. So you might be wondering why sir is taking as the minus sign here. Why he has taken minus sign here? Not the minus, but the approximation. Yes. Why the approximation sign has come? So students, it is not about, it doesn't actually equal to this, it is an approximate value. 1 minus x, and this happens to be n. Again, even sir is writing equal to sign. 1 minus nx, and this happens to be 1 minus x minus n, and this happens to be approximate 1 plus nx. Yes, students, this is perfectly fine. Example I would like to give of this. This is algebra that we will be using. This algebra you all know, and this is the new algebra that is being introduced here, and we will use it for further calculation in our course. So, example, suppose (1.02) happens to be cube. So you might have noticed that this value could be written as 1 plus 0.02 and again cube, and this value happens to be much smaller than 1. Then again I would put into the formula, and this becomes 1 plus 3 and 0.002, and this implies as a value as 1.06. Yes, so the answer is 1.06. Now the numerical part, certainly a numerical part, and we will end this story till here. 0.9793. Sir is getting wrong with numbers certainly, and this could be written as 1 minus 0.7, and this happens to be 4, and this could be written, no, this is equal to, and this could be written as 1 minus 0.28. Again, my speed is increasing, so you might not have got it. Minus 4, 0.007, and this implies 0.72 is the approximate value of this number. So I will stop till here. Thank you.